and welcome to another episode of the CG Garage. This is episode number 473, featuring Dan Ring, who is the senior lead of our machine learning team over here at Chaos. Really great guy. I've been wanting to actually have him on the podcast for a while. He's been part of Chaos team for a little bit, as you will find out. He's been working in the academic world for a long time and has been done a lot of work in terms of computer graphics and machine learning. He's also worked for the Foundry for a long time as well, and did a lot of work in terms of their tool CopyCat, which is really interesting. So we obviously have a lot of discussions on AI tools and AI in general and how it's being worked on in the visual effects world and in the computer graphics world. We have discussions on many, many subjects, including things like Gaussian Splats and NeRFs and things like that. And obviously about a lot of the how AI tools are going to change things, or what things are going to be different and what things might actually be the same. So really great to be able to talk to Dan and to hear his perspective. And actually it allows you to get a little bit of perspective exactly on how Chaos is thinking about some of these machine learning tools and how this will affect us as a company and the kind of tools that we're developing along the way. Besides that, I want to get you guys to know a little bit, a couple of announcements here. We have, I know you guys know a little bit about Project Arena, something that I've been working on for quite a while. Project Arena is part of something that we've been doing as part of Vantage. However, it is a separate part of it, and it involves virtual production. And if you guys are interested and have a stage, or you have or in virtual production space, you may want to know a little bit more about Project Arena. And therefore, just go to chaos.com/virtual production. Again, that is chaos.com/virtual production, and you'll learn more about it there. And you can sign up if you have a stage and you'd like to see a demo or like to be part of our development guys who are working on this. Speaking of Vantage, Vantage 2 Update 3 is out, and it has many new advantages to it, including layered materials have been added, and multi-mass has been added to our render elements, and there have been several UX changes that are definitely very, very useful. So again, go to chaos.com for all of those product announcements. In terms of events, it's again, go to chaos.com/events. We have an event on May 21st, 2024, and that is going to be at 4 p.m. Central European Time. We're going to have a webinar, and the title of the webinar is From Real-Time to Photoreal, Connecting Architectural Design and ArcViz Artists. We talk about a lot of our tools, including Enscape and V-Ray and Vantage. So make sure and check that out. If you're interested in that, just go to chaos.com/events and sign up for all of our events there. Now, if you guys want to know more about the podcast, you guys can go to chaos.com/CG Garage. If you'd like to follow us on Facebook, it's facebook.com/CG Garage Podcast. If you'd like to watch any of these podcasts, we post all of our videos on youtube.com/Chaos Group TV, which also includes the podcast itself. If you have suggestions of podcasts or guests you'd like to see on the podcast, you can just email us. It is labs@chaos.com. Again, labs@chaos.com. But for now, please enjoy Dan Ring on episode number 473.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passé. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
6 months? 7 months?
6 months. Okay.
Yeah.
I remember when Vlado told me, it was like, yeah, we got a new guy for machine learning, Dan Ring, and this. I think he was telling me about it like it was before it was officially announced. It was probably around SIGGRAPH, around that. It's like, we're hoping that this is all going to happen. So he was super excited about it. But let's get into that a little bit. So how long have you been in the visual effects side of things, or computer graphics side of things?
I was actually counting the number of years the other day, and I think if you count of doing my PhD and starting then, because my PhD was around user tools for how you analyze images and video, it's about 20 years.
20 years. Okay.
Yeah.
And so, when did that start? What was that? Where was that initial thing? Like when you went to school, it's like I love computer graphics, and that's what I want to do.
Yeah, pretty much, I love making films. I used to make films when I was 15 and 16 with my friends in school, and they would write things. I loved producing things. I loved building sets. I loved the editing of things. I loved getting images into the computer and then messing with them. We made a couple of really terrible films, like really like awful ones, and even ones where even as I suppose I was the visual effects soup for a few of them, where they were like, we want to shoot in sepia, the camera has a sepia mode, we'll put sepia on. I'm like, please don't do that, we can do that afterwards, but don't make that decision there. So very, and then after the fact, people asking, can we undo the sepia, can we fix it in post? So that was my first exposition to that. But yeah, and then in college I learned about like the maths behind how you do effects, and there was one particular lecturer, this guy Professor Anil Kokram, who it turned out he had connections to the Foundry, and he was one of the people who won the SciTech Awards for the motion kind of plugins for doing the Matrix bullet time. So all that. So he was my ended up being my PhD supervisor. And then my first project was actually
And where was this? Where were you studying?
This is in Trinity College, Dublin. So in Dublin.
Okay, yeah.
So we became good friends, and doing this project together. And the first project was actually not to do with like special effects or film or anything. Like he had this prestigious background, but it was largely around just analyzing images and video. And my first project was actually, it's going to sound weird and gruesome, but it was on parsing of medical video of cadaver dissections. So there are countries in the world that don't allow you to perform like dissections on cadavers, and so what we were doing was we were filming cadaver dissections. So I was being paired up with a first year med student who was doing the dissections, and I was filming it, and then we were both trying to figure out like what the hell we were doing. and then we would you would use algorithms for like tracking the scalpels, for tracking the kind of the utensils and the instruments, to kind of chop down, for a better word, the footage from hours down to kind of seconds and minutes of these important kind of surgical processes.
Wow.
So I survived that, and then after that I was.
Hold on. I mean, that's a hard thing to do. I mean, did you have the stomach for it? Did you think about that?
I didn't at the beginning. Like the first time, and if you've ever met surgeons, they're a different breed. They think differently and they behave differently. And the first time, they knew this was going to be an issue. The first time everybody sees a dead body, I think that was also in that film Stand By Me as well. And so they said, oh well, look, there's no way to get around this. And so the guy, we went back through his office down to kind of the lecture floor, and just whips back this tarp, and there's a cadaver there, and I immediately like lose control of my legs and fall to the floor.
Right.
And then they all have a laugh at at this, and they said, well, that's better than most people.
Wow.
So then I think it was okay after that, but then you get, what's weird is you get used to it all very quickly, and then you get used to. I was paired up with this other student, and we were then working with each other, and he was like, oh no, you move the camera here to get a better shot, and then sometimes I'd be like, oh, can you redo that incision there because we didn't quite get it, so you start building up this weird rapport.
Yeah.
But yeah.
Does that feel weird, like getting so nonchalant about it?
Yeah. Exactly. Yeah. And I won't even tell you about the tank, which is where they kept all the extras,
I'm sure.
the bits. But that'll be for a different podcast.
Okay. So this was about an editing process for education and medical science. So how were you processing this information? Were you processing it as part of your thesis or your work?
Yeah, well, so I suppose my role in this was to first of all just figure out like what type of algorithms could we use to process, like what bits are interesting, can we use algorithms to decide what movements of a scalpel signal something as being interesting. So surgeons actually do have, like, when they're talking about something, and you can see this in the textbooks, there's a visual vocabulary for how they move certain instruments. So, like, an incision will be a certain line. If they do it a couple of times, it means something else. They'll often do a loop with a scalpel or an instrument, or they'll make a twisting movement, and those indicate specific actions that you need to pay attention to. So the idea was, could we filter out the noise and just get to those clean movements and just edit down the video down to those bits? It turns out you can to some degree, but things like kind of liquids and specular highlights and all these other things get in the way of that. But yeah, in the end, we did come up with a set of these detecting interesting movements that do this. And that was kind of this whole theme of motion and movement was kind of followed me through my career.
Interesting. So you're basically, it is an image recognition system, right? That helps the editorial process as opposed to manually going through all that footage, right?
Yeah, exactly. And we also knew that getting an editor to edit this kind of footage would have been difficult. So
right. So you have to look through hours of people cutting up dead bodies.
Exactly. It's not something you can easily put up on a website and say, "Hey, want to do this?"
Okay. So how do you apply that to what you've done from there?
So after that and after the PhD, it became similar kind of techniques of, like, using motion analysis, image patch analysis to look for interesting stuff in images and videos. And then I did a postdoc with Foundry as part of an EU-funded project. So I was still on the Trinity side, and I was working with Simon Robinson and John Stark at the time. And so John Stark, now CTO of Synthesia. And it was great working with them on basically building plugins for matting, for motion analysis, for segmentation, some of the fun problems of compositing. And then after that, then they said, "Hey, want a job?" And joined Foundry, and that was for Nuke 6.3.8 time, a very good year. And and then the plugins I started making were around tracking. So it was applying kind of knowledge of, like, so the tracker, planar tracker, smart vector, camera tracker. They were kind of like the core ones that I was focused on building. So it was directly kind of applying that sense of motion and movement and understanding and similarity between neighboring frames. We didn't quite look at the, like, video parsing, because at the time we didn't have a place to do that. But yeah, motion understanding, I think that was kind of the big key and theme to what I've been building.
Okay. Well, that's fascinating. So motion tracking sort of was the beginning of it. How relatable is motion tracking to machine learning? How did that happen?
Yes, that's a good one. So when machine learning came along, obviously there's big hype and buzz about it, and we didn't know what to do. So we did what most people do, is we got in a couple of students who know more about this than anyone else. And we got them to put them to work on a couple of projects, and not usually around motion, because I think actually video is still kind of a hard topic in machine learning that hasn't been solved neatly yet. So lots of projects like, can you remove lens distortion from an image automatically? Can you automatically detect, like, what a lens is doing and de-lens it? Can you from an image, can you figure out what the lighting is in the room? Can you, for image-based lighting. So kind of simple constrained tasks. And it turned out on the lens distortion one, we got a neat result on that it turned out you could do it. And for some reason, it worked really well on images of cows. So like buildings that had, like, straight lines that were bent, then yes, those are easy. The other easy thing was cows. And we're never really sure why cows happened to.
What kind of cows? Is it cows with black spots on them? Like
like the Frisian cows,
Okay.
the kind of dairy kind of,
Dairy cows, right.
Yeah, but like
lots of tracking markers on them.
exactly. Yeah, exactly. So not really sure why that happened, but there was a really interesting kind of learning from that, and that like the machine learning algorithm, like on the first passes, we noticed that it was working quite well. We just got a great examples out of the box, and we're like, wow, this is great. We've just solved lens distortion. One of the common problems that affects every composite, every show, affects virtual production. It's one of the things that everybody comes back to. We're like, wait, we solved it. Machine learning model. This is it, done. Mm-hmm. And then we realized actually the way we created our data set is we'd created images, and we'd taken images and then we'd distorted them. We'd taken JPEG images, we distorted them and saved them as EXRs. And so obviously what we were doing was we were taking the JPEG compression artifacts that we couldn't see, but the AI could.
Right.
And it was just learning to, unwarp the compression artifacts. So it was the first. So in that case, anytime so it was never going to work for any real world images. And but it was the first
because you were doing it off web stuff.
Web stuff, exactly. Yeah. So just taking these, exactly. So that was the kind of first like aha moment that we're like, this machine learning can see things that we can't, and it can do things that we can't even, that we literally cannot perceive.
Right.
Or not easily perceive.
I mean, that's interesting. A little sidetrack on here. So a lot of these tools are trained on web stuff, right?
Yeah.
Which are all JPEG, compressed, whatever. That's what you find on the web. You don't find a series of high quality EXRs, high bit depth film stuff. So how does machine learning how does the training data affect the quality of the results if you're just dealing with crappy compressed images all the time that you're learning from?
Oh, Chris, this is the question I've always hoped to be asked. This is now we're getting into image formats, and
I told you we were going to geek out on this one.
Yeah, no. So it's a perfect question, and we spent a lot of time. So during the development of like CopyCat and the AI tools in Foundry, we spent a long time investigating exactly this, because we realized quite quickly, actually, just off the web images either wouldn't work because they're pretty low quality, or licensing issues just means that you can't use this, and you have to be very sensitive to licensing issues in our business. So what we realized then is, if we want to get like high quality images, and also so we can try use high quality images and see what we get. But of the images that we were training with, and these are even ones that we've shot ourselves, if you didn't pay attention to the color space, first of all, that was the first killer. And the main thing there is that all of the algorithms that have been and frameworks that are out there, like from PyTorch, TensorFlow, all of them, they've all been tuned for images that are in sRGB color space, and they're all in like standard definition, so not high dynamic range. And what this means then is that anytime you put in a linear image into it, you're not guaranteed to get the result you want out of it. In fact, you're probably not going to get it. And this happens both in training and inference. And so one of the things we had to realize then is anytime we were doing training, so for in CopyCat, one of the tricks that we had to do was convert everything to sRGB. So it can still be
quickly before we get too much into it, people are going to ask, because some people, what is CopyCat? Explain out the CopyCat.
Okay. So yes. So CopyCat is most machine learning tools that you'd use in software are just kind of one click. You put an image in, you click a button, and you get something out. Sure. CopyCat was a way of and for those tools, they do one thing. Like if it's denoise or deblur or something like that, they do that one thing.
Sure.
CopyCat the idea was to try and understand, like, could we allow artists to train on their own images to solve their own problems. So and this works pretty nice because a lot of artists in compositing, they spend a lot of time working on hundreds of frames, but not thousands, and not a full video. And they could spend weeks or months on a single task of changing the color of someone's eyes across an entire shot and across hundreds of frames. So something that would take a very long time, but it's quite repetitive. And the idea with CopyCat was, could you do this on a handful of keyframes, and then could it interpolate and guess how to apply that same effect to all the other frames? And this could be for, helping with rotoscoping, like masking, but also any other compositing effect. So if you're doing like blemish removal, if you're doing spot removal, marker removal, changing eye colors, anything like that. Pretty much any kind of, and we found that like it worked pretty well on most tasks. And this was another kind of like, kind of big moment for us when we realized that this magic network that we discovered and developed, could really generalize well to letting artists define their own problem that they want to solve, and then solve it for that shot. Now, the catch is that it generally only works for that shot. If you try and use it for other shots, it might work, might need more training, but that's CopyCat.
So it's interesting. I remember there was a film I worked on years ago, several decades ago, but one of the actors had it in their contract that their eye color had to be 50% more saturated in any shot that they were in.
Yeah, exactly. Yeah,
that happens a lot.
Yeah, and similar things like beauty marks or moles, like moles that somebody, like an actor, has developed later in life, and that they want to. They don't want to look as old. So
yes.
So lots of things.
And it's interesting. I'm very close to someone who does a lot of digital cosmetic work, so it's very interesting to see that, because that's actually a very subjective tool. Yeah. You can't automate that as much as people think you can.
Yeah, exactly. Yeah,
people, it's like that mole I want to keep because I've had that as part of my signature, but that other mole, that's a new one. I want to remove that one.
Yeah, exactly. Yeah, exactly. And the like trying to lock into a certain age as well. So like exactly that, being trying to, I want exactly this many lines on my forehead and crow's feet, but not too many. So it's Yep, it gets very specific and very subjective, and everyone has their own thing that they want to do. Yeah.
Okay, so that's interesting about CopyCat, and so it's basically your little mini machine learning tool that you can put on the side to sort of train on your own stuff, right?
Exactly.
Okay, that's cool. All right, so let's go back to the problem with the high bit depth and high quality images.
Yes. So then going back to that, then the challenge was that we realized quite quickly that if we just kept things in linear, like if we just treated everything as like, so in Nuke, most of the images that you process are in linear color space, and we realized the model, it would work pretty well. But for a couple of things, and particularly with the like the deblur node that we had, it would do funny things if you gave it in high dynamic range images, or if you just didn't put them in as sRGB. So all of our training and testing was all done through sRGB, and then when we applied it through linear, we would just get different results. So we realized, we had to convert everything to sRGB in order to fit it into the framework, the PyTorch or TensorFlow or whatever that that expects sRGB. So that was the first thing that we just have to do, and we never found a kind of a good way around it. It's always just the
and you couldn't do it the other way around, right? You couldn't train it on linear data.
Oh no! Even if we trained it on linear data, it's still the behavior of the training, both the behavior of both the training and the inference was affected by something intrinsic in the framework.
And that's because of the way the tools that you were using just didn't understand linear space, or were never trained on it.
Exactly. Well, I think it's more that they weren't tuned on it. So all of the guts of all the optimizers that happen within, and the back propagation, and all of the kind of the various layers that would be common in any kind of machine learning architecture, they were just by nature, by over the decades of development, were just on web images, which were all sRGB.
Right. Yeah.
So yeah, just by nature of the tuning, you just got this extra performance boost or penalty, depending on which way you look at it, by just going sRGB. So that was the first thing.
This is interesting because I think this is going to continue to be an issue, right? Yeah. If you're seeing all these tools that are out there, they're all trained on H.264 data or JPEGs or whatever, right? And so that is far, far, far cry from a 16-bit EXR,
yeah, exactly.
right? Or a ProRes video.
Yeah, exactly. And then when you get into HDR images, more funny stuff starts happening, because you're now like most, to simplify it completely, most machine learning frameworks, they prefer images to be between 0 and 1. Now you can apply lots of functions to normalize images to 0 and 1, but with HDR images, there's no limit. Like, depending on the camera, depending on whether it was rendered, you can get image intensities, or pixel intensities of anything.
20, 15, 100,000.
Exactly. Yeah, exactly.
Right.
So how do you normalize those, and how do you make sense out of those? And again, there are ways to do this, but you're then changing the image statistics. And you're adding your own bias into it, and as soon as you add your own bias into any of these systems, bad things start happening. So again, for this, we noticed with HDR images, when we were doing deblur, we would get kind of weird issues with certain colors, like reds would stop being red. If you just put in a high dynamic red image, it would come out just slightly changed, and
wow.
And it would, so that's immediate. There's something quirky going on here, and then we did a lot of work to figure out how can we fix this and how can we tune this, and the simplest answer was to convert it to a different color space, like choosing the Alexa log. I think was a nice conversion format, but that was still a compromise, and it's still not the right way of doing it. It's still not the
right.
It's still, you're trading that off, and then something else will pop out somewhere else. So you're constantly fighting this battle of basically anything. As soon as you depart from, like standard dynamic range, low dynamic range and sRGB, as soon as you depart from that, you're kind of inviting trouble.
Right. Yeah. So it's like you're putting sunglasses on your system, and then you're like expecting it to see everything, because it can't. It's just, that's the way. Yeah.
Yeah, exactly. Yeah.
Very, very interesting, and it's gonna follow up on a question I'm gonna have later. But before we get into that, let's talk. I want to, obviously there's a little bit I want to sort of understand about machine learning. I would like our audience to understand. I think I do, but I want to make sure we have some vocabulary behind us. Let's talk about generative image generation, or generative AI. And obviously this has been a big subject that's happened quite a bit. So before we get into that, let's talk about that process. Since you are an expert in this area and we can rely on it, I would love you to explain to me how text to image or text generative AI in that sense of things works. Like, how do you train it? What does it do? What is it actually doing to generate that image? What is that process that a machine is doing to make that happen?
So if you mean about generative AI for the idea of like stable diffusion or mid-journey or something like that.
We can do stable diffusion as an example, but obviously anything that you're generating something, like it's reading something and outputting something else in some other way.
Yeah, so I suppose there's two parts to this, and I think the first is this idea of like a latent space. So what is a latent space? If you remember back in 2019 when deepfakes kind of sprung out, one of the neat things that it showed, people have known this for a long time, but deepfakes really kind of showed it, is that there aren't an infinite number of configurations of your face. Like there is a space that can generally represent very, very easily, like a compact space that can represent your face, not like by a small number of numbers. So this idea of a machine learning this. Sorry, the idea is that if you had imagine a 100 by 100 pixel image of your face, you don't need 100 by 100 pixels to represent your face. Actually, for your face or my face, we can probably compactly represent it by probably 10, 20 numbers. So not 10,000 or anything. And people have known this for quite a while. There's lots of work on like principal component analysis that shows, for facial recognition, we know as well that we can represent people's faces by a small number of numbers. And what deepfake showed was actually, particularly when you get down to specific people's faces and you want to look at like the variation of how people's faces move and all this, you don't need that many numbers. And the way that you find out what these numbers are is that you train a model to learn all the appearances of a face, and then find out the transformation that takes any image of your face and figure out those magic numbers that represent you. And that space of those magic numbers is called like the latent space. So it's just a smaller compact way of representing these of things. So it turns out we can do that not just with faces, but we can do that with everything. So we can turn out, like, you take images of everything, and you learn, like, if you've got all of the images in the world, you can learn this latent space that maps any image into a smaller, more compact version of things. So again, you think that, like, there is an infinite set of images out there, but there's actually not. If you think of, how many images of random noise do you see, like, in real life? Like 0. Right. Things are pretty well defined. Light behaves a certain way. We generally image things in our cameras in a certain way to capture light between certain levels. So there's a lot of structure in kind of the images and a lot of repetition and redundancy. So the first step is to compact, reduce your size down of all of your images down to this. This is
find the latent space of everything in the world.
Latent space of everything in the world, exactly. And then the neat thing that they do with this is there was a model called Clip, and Clip is this lovely model that it relates to captioning images, and the idea is like you have you give it an image, and out of it you can get the text, and you can get a caption of it. So it has this relationship between text and images, and it knows about this.
And where does it get that information? It got that information because it learned from an image that had text. Exactly. It went to find it, right?
From a huge database that compiled by people manually writing captions for hundreds of thousands, millions of images, a crazy number. And so we have this mapping now between images and text. Now it's not a very good mapping. Like, there are better versions of it, but Clip was the first one to do it in a way that was good enough for these purposes. Mm-hmm. So now here's where the neat thing comes in. So we've got our latent space, we've got this model, and then on one hand, and then on the other hand, we have this way of marrying images and text. The neat thing then is that what we want to do now is find a way of, starting with a random noise image. So in the latent space, we give it some random noise. And so we start off with a completely random noise. And the neat thing that these diffusion models do, and so what we're going to talk about now is diffusion, and the idea is based on the principle of kind of, physical diffusion of heat or particles. But what it actually kind of boils down to is this idea that you take a noisy image and you learn how to denoise it such that it looks like the thing that you want. So imagine you have a text prompt of a bunch of cats riding a train. Mm-hmm. So you take your bunch of cats riding a train, you put it into your Clip model, and it gives you out this sort of vector, that this embedding, and that embedding is sort of unique to the sort of the hold on a sec, let me get this straight. That embedding is just another set of numbers of sort of fixed length. And what we're going to now do is train the model to know that, to give it, it knows about like cats, it knows about trains, and the idea is to find the mapping between the model of, find the mapping between the latent space and the vector space that the Clip model is giving you. And we're doing that I hope you can edit this.
I'm following. I'm still following.
So the idea is to connect the the clip model with the clip model with your latent space, such that you can take a random image of noise in the latent space and denoise it so that the image looks more like the vector that clip has given you. So
Right.
clip is saying this. Here are the numbers that say these edges correspond to a cat riding a train. I want you to learn to create a model that can iteratively denoise this any image, so that you're at each step you're getting closer to an image that looks like cats riding a train.
Right.
And you do this for every image you have. So you're learning to go from to take a random noise image, and you say, okay, here's an image of cows that look like they've been lens distorted. And that's a vector, and then you iteratively learn how to take your noisy image in the latent space and denoise it, so that it then by the end of the denoising process it looks like cows that have been delensed.
Right.
And that's your generative model, and then that's your model has learned how to diffuse that, or to denoise that. And so then when you then come along to your when you want to generate an image, then you put in your text, and then it says, oh yeah, I know your text. Like, you see your text. This is the vector. I'm going to take my latent space here, and I know exactly how to denoise my random image so that it will look like the thing that you want. So
Right.
it's essentially a very clever denoising process that takes into account kind of the connection between text and images, as well, and then doing this all in the latent space so that we've simplified the problem to make it tangible. So that was kind of the key learning from that.
Right.
Hopefully that all
I think
makes
that's
sense.
a good explanation, the basis for my next question. Okay. So that's good. So now that is the process in which images are generated. A lot of images are generated this way. Tons and tons of images. People are making, Kim Kardashian riding a hot dog, whatever, out of these systems, right? Now, I have created images in CG for years using two different systems, one called rasterized rendering and one called ray tracing, right? And so these systems have been around for a long time, and ray tracing actually is kind of it's a way of denoising by adding more samples.
Yeah,
in
exactly.
a way.
Yeah.
So let's talk about that. Like, how will that process, is this a new way of rendering that would essentially solve another problem that will rasterize and ray tracing solutions become obsolete through this new system in some ways?
Very good question. I think what a lot of people want me to say is, like, traditional rendering is dead. Long live AI rendering.
Is it?
Yeah, I mean, I don't think so. I think one of and that's a kind of a bigger topic is this connection between the real, like, grounding in reality and the connection of reality to AI. And I think that's what, like, with generative AI, the biggest challenge here is control. How do you get the thing that you want versus just anything? On specific rendering, like traditional rendering, either rasterization or ray tracing, we're already doing a little bit of machine learning for a lot of these things already. There are commercial denoisers out there that will take kind of low numbers of samples and then suddenly give you a magic image. I could completely see a world where you take a few kind of samples of rays that you cast, and then using AI it just interpolates the rest. Like, that's a really easy kind of world.
Essentially, isn't that what ray reconstruction is?
Yeah, exactly. But the interesting bit then is, like, how far do you want that to go? So at the moment we're doing things like denoising, which is it's giving you the thing that you would have gotten if you just let it run for more samples for longer. So it's just giving you a shortcut there. But the question then is, do you want it to give you more? And at what point is it giving you more than you asked for, more than something that you didn't want? And this is where we get into the fun discussion of, like, how much, like, is it giving you something better? Is better what you wanted? Is this like, do you want more control? Would you prefer to have the original thing just faster? Would you prefer, like, what if it could give you what if there was a network that in, say, Vantage, it gave you, immediate high quality global illumination. Like, is
Right.
that what people actually want? So there's this balance between like kind of the control over the thing that you want, versus like the enhance button, the make it much more better right now button. And I think that's where things get really interesting.
Yeah. It's so when if I go back to the early 2000s when I really started to get into ray tracing as an artist, right? The reason I liked it so much is I didn't have to do all this freaking work to try to make something look better, right? Because rasterized rendering can look very photoreal, but you have to really work at making it look real. It's not out of the box solution.
Yeah.
And what I found when you ray trace it, it was much more like a photography tool. And I could just if I just do it right, then it's right. And I don't have to think about all the other things that I have to do. Right.
Yeah.
So what I'm curious is one of the things that is sort of very exciting with Vantage is that ray tracing information actually has a lot of when you get a ray back from the virtual space, you're actually getting a huge amount of information out there, right? So can that turn into more than with a little bit of machine learning rather than just have to sample it a bazillion times, right?
Yeah, exactly. And I think that's a really good question of like what is in that scene, and then the other question then is when we do a lot of rendering at the moment, we use a fixed camera position. Is that what we want? Should we should we have to decide on a camera position before we render something?
Okay.
Should we be allowed to do the processing, do the heavy processing, and then decide the camera later, decide the lens later?
Right.
And then we start getting into the field of NeRFs, like neural radiance fields.
Okay,
Gaussian
stop.
Splats. I'm going to stop.
Wait, because I want to get into this too. Okay, so that's perfect. Yeah. So probably many years ago, I don't know. I mean, I think the statute of limitation is not this, but we had been working with a company called Lytro for a while.
Yeah.
Right. And so they had obviously been working on light fields for a long time, and I was very interested about that because specifically one of the things that they were talking about was you can derive more with a light field than you can from a single image, right? And that you can derive not just it's not just photogrammetry, right? It derives the rays of light from many directions, and then therefore reflections are correct and specular highlights move, and everything it's about the light, the volume of light rather than the volume of geometry.
Yeah.
Right. And so I was very curious about it, and they wanted to do stuff because I said, with ray tracing, we can do this synthetically. And I was thinking about how we were going to do this. And I was like, this is so much redundant information. They needed, 10,000 images to create one light field. And there was so much redundancy that we were doing in that. I was like, there's got to be a machine learning way to make this faster where you only need a handful and it derives the rest. Which is isn't that what a NeRF is in some ways?
Yeah, exactly. And the overlap there was amazing. And we like in Foundry, we had also kind of worked with Lytro a little bit on some of the post-processing workflows. They were like, how do we do compositing on a light field? And, and that was bananas. And that later
so much data.
Yeah. And that later led to a project that we had called Volume Magic, which was around using multiple cameras, not like the amazing mega camera that Lytro had, but using 40 synchronized Zcam E2s, which I love. I've got a few of them here behind me. And then the idea was can you how many cameras do you need to capture a volumetric performance, or it's not full light field, but can we approximate it? And we came to a workflow where we're using depth and doing lots of structure for motion, being very careful about modeling the lenses correctly, and we got pretty far with this, and we had a nice workflow, but it was still lacking. It's still very because there were so many steps. It fell apart at one of these steps, and then by the time we got to rendering it, we were using Unreal, or we were even using the Looking Glass displays to display these things. And by the time we got there, it just didn't quite feel right. Some bits worked, some bits didn't. And then NeRF came onto the scene. Just before that, it was like local light field fusion was the kind of the hot topic, and we had like multiplane images where people in academia had reinvented deep images. So the idea of deep images being where you've got multiple samples per pixel along the camera array, and we were delighted with this because that was going where we wanted to. And then all of a sudden, NeRF pops out with this really elegant equation, like only a few lines of code to come up with something that's really incredible, like visually impressive, and doing all these wonderful things. And yeah, exactly like that where you're sampling proxies of light, and going back to the latent space. Like, I mean, essentially, NeRF is a data structure for capturing the redundancy from all of these images and all these patterns, and just using the regularization properties of models. So regularization being like, if you're looking at an image you're rendering an image from one view, and you go slightly to the left, it's not going to give you a completely different view image. It's going to give you something that looks pretty consistent. So even if you're interpolating between views or interpolating between things, and this is also the secret behind CopyCat, is that it turns out models are these particular, like machine learning, it's quite good at filling in the gaps, and this is what NeRF had figured out, and because it's able to do that, you can reduce your 1,000 images of light field images into quite a compact little 3.4 megabyte NeRF model.
Right. But but right around when everyone was starting to jump onto the NeRF thing, it's like, oh, this is going to change everything. And then Gaussian Splats came along. So what is the difference between a Gaussian Splats data set and a NeRF data set?
So the Gaussian Splats, this actually depends on who you talk to. There's a lot of computer scientists who say the Gaussian Splats, they existed a long time before. And even in my PhD research, I used these things I modeled Gaussians for thing called kernel density estimation, which I was using for image and object segmentation, for like segmenting people. And you could model the distribution of a person's pixels based using a mixture of Gaussians. So everyone knows the Gaussian bell curve, and if you do that in RGB space, like in 3D, you can get quite a nice shape, and then that allows you to model a volume in 3D space. And if you use multiple Gaussians, these things, and you can model not just skin color, but my hair color, my eye color, my sclera color, even the detail of the grayness, the grays hairs in my beard, as well as another Gaussian. And then if you use those, then you can do a key or a mass by easily sampling from those Gaussians. But if you want to figure out those, those models separately, or where those Gaussian, those kind of spheres or spheroids live in 3D space, you have to do an optimization step. And in the olden days, this was often done through like expectation maximization was one algorithm. K-means was another clustering algorithm for doing this. But the neat thing about this is that Gaussians are really well behaved. The mathematics behind them means that they're you can take the derivatives of them at any point, which is derivatives are great for optimization. They're great for machine learning. We all like all of the. I'm going to get into detail. Actually, no, I'm going to avoid getting into detail here. But the neat thing about Gaussian, working with Gaussians, first of all, is that they're quick to optimize. They're quick to find things. They're quick to hone in on the thing that you're looking for. And in my case, when I was doing matting and segmentation of people, I was only dealing with maybe five Gaussians. For Gaussian splatting, which is this a way of modeling the world from 3D to space, it's modeling Gaussians in multiple dimensions. So five, I think at least 5 dimensions, as well. So it's modeling the RGB or the camera space, the camera position that it's looking at, as well as other various parameters. And it's optimizing over thousands of Gaussians, so or tens of thousands, possibly like even millions for depending on the size. But this is all tractable. This is computation possible, and this wasn't before. So it's basically Gaussian splats are leveraging they're taking the neat idea of NeRFs being a data structure, a very clever, elegant data structure, and they're taking this decades old idea of modeling the world or modeling parts of the world through Gaussians and taking it to the nth degree in the fifth or more dimension, and then allowing you to model the world through these like very simple, well-behaved, mathematically well-behaved shapes. And what you get is a very neat way of modeling the world, and then also, most importantly, extremely efficient to render. So the catch with NeRFs is that for every ray you want to sample, you have to poke the model and get a sample. And every time you poke that model, it is pretty efficient right now, but there's no comparing to how efficient modeling and sampling from a set of Gaussian functions is. So
Interesting.
So hopefully that's a.
It's much okay.
Yeah.
So is okay, but you're still casting rays into Gaussians or finding out, are you or not?
So most operations for this are all rendering through rasterization. So it's
as a rasterized solution.
It's very easy to kind of go over the whole space like that. You're still using you're still defining the world based on 3D shapes and rays and positions, but it's still all rasterized. Now,
interesting.
In the innovation lab, as you're well aware, Asen has been doing some great work on converting this to ray tracing, like to allowing you to ray trace Gaussian splats.
Yeah. Which I'm going to get to in a second.
Okay,
but,
cool.
Okay, so we're now talking about a different kind of structure, a different way of looking at the world compared to what we've traditionally been doing, which is to define things as polygons and shading groups and a reflection, PBRs and stuff like that. Is because splats do not involve polygons. NeRFs do not involve polygons, yet somehow it still defines the space in some ways.
Yeah.
So how is this going to? Are we going to see a replacement? Are we seeing polygons going the way of the dodo in some ways?
Yeah, that's a good question. I mean, there've been lots of other, structures and formats for how you represent 3D in the past. I mean,
Sure.
You can go for pure parametric volumes, like just mathematical functions to define things.
Yep.
There's like the constructive solid geometry approach, which you can take any form of any way you define your shapes. And then there's also like signed distance fields as well as another way of, kind of constructing things. And they all have their strengths and weaknesses. And, if you ask somebody who's, who likes modeling with signed distance fields and sculpting faces and things, like they love that. Like they really like they don't want to care about polygons or meshes or materials even, because they're not at that stage.
UV maps.
Yeah, exactly. Yeah. Don't want to care about them. But then once you kind of get down to a certain level, and when you're interfacing with other people and you have performance requirements, then you need something else. Signed distance fields are also really great, and another example of well-behaved functions for which mesh with machine learning quite nicely. So you'll see a lot of like machine learning papers using signed distance fields as a way of dealing with geometry, because meshes and vertices and polygons, there's not an easy way of getting them into or out of machine learning systems at the moment. And it's one of the main reasons we don't see a lot of like the same level of interest in 3D as we do in 2D in generative AI.
Mm-hmm. Right. Okay. All right. So listen, this might go long. Are you cool for staying long on the podcast? Okay, good. Because we still have a lot to discuss, and I want to get through a lot of this,
sure.
Which is very cool. Okay, so we have what I've been trying to do in this secretive way is develop a language of all these different things. So we've talked about generative AI, we've talked about 3D things, we've talked about a bunch of other things. And then now I want to sort of talk about a little bit about, you're sort of starting to hint at it, about the Innovation Lab and its initiatives in machine learning and AI. So when you came on board to Chaos, you were given some ideas of what you wanted to look into. What were the things that you wanted to look at, and what were the things that you sort of explored that were strengths that Chaos could apply some of these new technologies?
Yeah, so interesting. When I was like kind of brought on to Chaos, like I chatted with Vlado and Cam, as Cam Starr, that's our chief product officer, and I had a couple of chats, and I wasn't interested in moving. Like I was like Foundry is wonderful. Foundry's a wonderful place to work, and gradually, like after a couple of chats, like Cam and Vlado just painted this very clear vision of like kind of what they wanted to deliver, and also demonstrated the kind of capabilities of delivering it. And like I can't talk about like kind of the very far future things,
no,
but it was compelling enough and exciting enough to me to be like, right, like this is where I need to be. This is the future. And the like if we're talking specifics on the things I can talk about and generalities and the things I can't, they painted a really nice picture about like solving some very kind of fundamental and core problems that people have today. So we're looking at things of like material generation, like image enhancement, applying generative AI to creating like in the Celindo world of like e-commerce, of creating lifestyle images. And some of these are like I've been very privileged, even in the first couple of months of creating or getting to work on something that to build something that nobody has done before. And I talked about this in the FMX talk last week. I can't, like, it's one of these things I can't talk about how we did it. And I'm not sure if there's anything up yet, but for anybody listening, stay tuned to the Celindo releases. There's some really, really interesting stuff there. But anyway, that was, for me already, 2 months in, the career highlight.
Awesome.
But where's this going? It's like this lovely mix of stuff that's hard to do now. Like the materials. So just improving quality of materials, giving you access to kind of a greater variety of materials. To then other stuff like automatic furniture placement is another thing. So how do you populate a space with given an asset library, and how do you do it intelligently? How do you make it look, how do you guide it in a sensible way without having to place every individual asset? And this then kind of has greater ramifications for, how do you imagine you've modeled a cityscape. How do you extend your city? How do you make it look believable? How do you guide that development in a way that again fits certain requirements, that it has a certain style or a look, that it's not just a procedural kind of thing. It's allowing you to guide and direct the creation of these things. So being able to work on specifics and then take it out to scale and still have that the feeling and the guidance of the specifics work at scale. So that's another thing. And then, we're obviously in the Innovation Lab looking also at things like NeRFs, Gaussian Splats, and that's really exciting. And like it's because it's such a, I had a look to see kind of like how many papers have been created on that over the years, and since the first paper in 2020, there's been over 1,100 papers in that field. And that's 1,100 to date. And that's, if you look at the projections of where the number of papers are for this year, the projected number, like if it keeps going the same trend, will be over 1,500. So it's huge. And so there's lots to go in there. And as we've discovered,
how do you make sense of that? Like just having what you think was cool at 11 a.m. is outdated by 4 p.m. of the same day. You know what I mean?
Yeah. Like the number of times I've said, oh no, that isn't possible. Nobody could do that. And then somebody on my team shows me a paper. There's like, this just came out yesterday saying it's done. And this happens a lot. Like wading through the kind of the signal to noise kind of a thing at the moment is tough. I've asked other people in similar positions in other companies how they do it, and there's just no easy way. You rely on your team. Like I'm really fortunate to have a very clever, very strong team in both ability to kind of get stuck into papers as well as deliver stuff. And as well being surrounded like in chaos. One of the things that compelled me here is like the level of knowledge and the sheer competency of engineers here, and the breadth of knowledge as well that is in this company is marvelous. So there's never a time I've never felt at any point where there isn't somebody I can ask for help.
Right.
So, and then I think as you know as well, internally we have a lot of discussions of on AI topics, and
Yep.
people who already kind of like filter out, like a lot of people in the company already do that filtering of noise out, so that we're left with
I will tell you this, the Bulgarians, I'm not making a generalization, I know I am, are excellent at filtering noise. They do not jump on hype trains by a long shot.
No.
This is a very American thing to do, is to jump, especially in California. We love to jump on hype trains. but they are very good at saying, hold on.
Yeah, no, I would fully agree, and they fully get to the meat of the paper very quickly.
Right.
Like here's the crux, here's the hook, and then
Right.
apply that and share that, and like particularly in the company, they're very good. That the folks are great at finding out who specifically they need to share this with.
Sure.
And so I've loved that. So I mean, that's been my secret to kind of helping wade through this space. But yeah, I mean, if you were doing this on your own, if you were in the kind of an isolated research group, I think you'd be out of your depth very quickly.
Yeah, absolutely. I mean, I think it's fascinating, right? Because it's this is something, as I've been part of, my job at Chaos is coming up on 10 years, and I've been sort of looking at a lot of different things, right? And I've seen a lot of these hypes go up and down in different ways, right? I mean, let's just, start. When I was starting, there was a lot of things going on around VR, and VR is still a very valid thing, but the expectation of what we had for VR, if you go back to 10 years ago, was completely different than the reality of what it is today.
No, exactly.
Right.
Yeah,
and then, and so I've seen that growth and that idea. I still think it's a very valid thing. It's just not, didn't revel. And then the same thing, like, go back to 2020 with Web3 and NFTs. Oh my God, that's, that is a big change. But again, I just saw a hilarious cartoon where there's a guy sitting at a computer and says, can we just do a search and replace for all words that say NFT and replace it with AI, like for our deck, right? And so is there a sort of AI hype train that we're dealing with right now in terms of what a tech company is expected to do with AI?
Oh, absolutely. I mean, there's no doubt that like there is a hype train associated with this. Does that mean that AI isn't going to live up to the hype eventually? I don't know. Don't think like, I mean, I think the more we're seeing, the more incredible things the more incredible things we see, the more incredibles we're predicting we're going to see. And I think that's been really interesting. And it is, it is backed up by, like something like Sora comes out and it blows everybody away. And there's, gradually like the naysayers or the doubters are like, well, actually this could have a thing. This could like, and I mean, this is AI is absolutely transformative. There is no going back. The genie is out of the bottle. One thing that I do also think, though, is that the hype of AI is having more of an effect than AI is currently doing today.
Okay.
And to give you an example of this, like years ago, the Foundry, we got approached by a company who was very specialized in doing very high-end kind of face replacements, de-aging work. And this, they got they came to us and said, hey, look, we're being asked by our clients about deepfakes. And we want you to do this next project with deepfake. We're not going to pay you the money we paid you yesterday for this thing. So either you do it with deepfakes or you're not doing it. And we expect deepfakes.
And we want to pay you less.
We want to pay you less because deepfakes is out there. And like my kid nephew can do it in his bedroom, so we're not gonna, we don't want to pay for that anymore. So,
by the way, I found that when people say that, I say, go ahead, do it. I'll see you in 6 months.
Well, this is exactly how, I mean, it's how it turned out. Like the project went ahead with this, and like it ended up working. Like they managed to kind of get the right people to deliver it with deepfakes, and it was a great learning exercise and everything. But very materially, like, and they said about this is that overnight, what they could charge for something changed. And this was without knowing about the capabilities of AI. And I think in terms of, was that cheaper? Like, did that work actually cheaper? Probably not. They had to go external to do all that.
Right.
But there were lots of examples of this, and I think even the when with the actor strikes and the writer strikes, and the connections to AI there. It's also the perception of what AI can do is having, like, people were getting hung up on arguments of what ifs before any of this stuff has materialized.
Yeah.
And it's not that it's not valid, but and because all of this could be, and like the hype could be justified, and this is transformative, but very concretely, this is a material effect is happening on the hype of AI, not what AI is currently doing.
Yes, agreed. So beginning of 2020, just before the pandemic, I was actually on several panels, at the end of 2019, on deepfakes, right? Because I've done a lot of stuff in digital humans.
Yeah,
it's one of my other things that I love to talk about. And so I was asked by several people to be on panels, specifically because they're all terrified of deepfakes, right? End of 2019, 2020. And it was like, it's an election year. People are going to steal the election with deepfakes. And turns out they didn't need deepfakes to do it. Yeah. People just straight up lied, and that was good enough for trying to convince people to vote for you, right? You don't need the technology to get there. It's just human perception is more into it than that, which I think is very interesting. Now let's talk about a little bit, like, we create tools that are very important in terms of very high quality renderings that are used for very high quality work, right? Yeah. And there's a lot of things like, well, now I just go into freaking Stable Diffusion and that's done, right? Yeah. So that's not necessarily the case, right?
Yeah, very much so. I think at the very simplest, we're seeing that. So I suppose taking a step back, when the generative AI stuff popped out, everybody was saying, "Oh, well, that's it. Graphic designers are done for. We're never hiring a graphic designer ever again."
Sure.
And if you look at like the number of AI generated images that you see on a day-to-day basis, it's probably not that high. It is out there. You do see it used for advertising, and they are used for concepts and things, but it's not everywhere. It's not, and it's the tools out there are fairly mature, and you can use them quite easily. But what we are realizing is that there are quality gaps, and there's also creative gaps where you just can't creatively direct the thing that you want and get a reliable, consistent result each time. There are ways to improve that, and actually that thing I mentioned, the highlight of my career was we figured out a way of taking merging merging a render of a chair. Well, of any things. You probably know the one I'm talking about. I get very hyped about this chair. So it's a render of a chair, and you want to put a virtual background around it.
Right.
And normally, if you ask Stable Diffusion to generate you this, there are kind of compositing tricks you can do to get this. But in order to integrate it, you have to change the chair a little bit. In order to, it's basic compositing, because the chair was rendered in a completely different way, a different background. And so if you want to put in an interesting environment and have the lighting correct for your chair, it's actually quite hard to do. We figured out a kind of a really neat workflow for doing this, and it's something that we haven't seen other people doing. But this was the thing that allowed you to, again, and the reason why do I care about not changing this chair? It's because in e-commerce, you're selling this chair. Like, if Stable Diffusion changes the chair to make it look more edgy, like imagine if you're, you make it more modern or more or more Scandinavian looking, like that's not what the real chair will look like. So you're not allowed to change it, but you want to change it enough so that it integrates with the scene. And that's the kind of a neat thing that we figured out. And again, I'm looking forward to when we launch this and people can see what I'm talking about. But this is cool, and this kind of comes back to both the control point, but then also the quality point. Is that it's not just the the quality of the image, because Midjourney and Stable Diffusion and Excel and all, they can generate photoreal images. Like the quality can be pretty good. Like it's certainly plausible for a lot of things, but without that quality of control, I think that's the thing that you'll always lack.
Yeah, absolutely. Okay, so let's talk a little bit about, I'm working on a short film, as you know, and we're dealing with a bunch of very, a workflow that you would use in a feature film, right? We're dealing, everything was shot on Alexa 35. We're dealing with log space. I can't go in to Sora and tell me to make something for me right now, because Sora is trained on crappy MPEG-4s off YouTube, right?
Yeah.
So I'm not going to get the dynamic range to get that sunlight flare that I want out of it.
No, exactly. Well, actually, I mean, if according to the CTO of OpenAI, they don't know what they trained it on.
They don't even know what they trained it on.
Completely unknowable. But yes, but assuming it might have been YouTube that they trained it on.
Sure. That's the most logical place to go. That's huge amounts of data, right?
Oh, for sure. It's just in a recent interview where she was asked, what was it trained on? Gave a perfectly political answer of like, we don't know. It could be lots of things. Public material, it's fine. Yeah, exactly. But yeah, perfect answer, perfectly political answer. But yes, going back to the flares and HDR, yeah, while there are tools out there that can fake HDR and give you kind of, give you better kind of flare and things, they're not great. They don't work very well. Again, they're kind of guessing at what should be there. And yeah, you might be able to improve it, but you're right. It will always have that look. And actually, there's a lot of DPs who have looked at not just generated image from Sora, but also from Stable Diffusion, and people are saying there's a look to it. When people are saying, "Oh yeah, can you tell if it's AI or not?"
Everything looks like a morph target.
yeah. Exactly. So what about that?
Everything's kind of like, just like, yeah.
Yeah, exactly. Yeah. So, I mean, certainly for any of the video stuff, but even the specific images, if you get an image of a person, like people are able to, humans are able to reliably say, yeah, that was AI.
Right. Yes. Which is interesting. So it goes back to my first point, or where you first talked about, like, it's hard to train AI on high dynamic range or deep pixels or linear space or whatever, right?
Yeah, exactly. Yeah.
Because I'm sure Sora was trained on sRGB space.
Oh, for sure. Yeah. I mean, maybe for some of the YouTube stuff, there is some. I mean, there's some HDR stuff in there, but probably the vast majority of it is SDR, and even if they took in the HDR, they would have had to do some conversion on it, like, or either clip it or compress it and do something with it. But again, they could easily have just rejected it and said we're not training on HDR.
Right. So what's interesting is if you look at what we're sort of doing, what you've been doing in the spaces, you've actually been working on AI tools and machine learning tools that are geared towards our users, not towards non-users. Right? Yeah.
Exactly. Yeah. I think that's kind of my main thing. That's my main hook, is like I've always could have cared about who uses the thing that I'm making.
Sure.
And that's like it. I'm happiest when I see I see somebody using tools and that I've made, it's sort of not even that I've made, well, obviously what I've made, but that my teams have made, and like that's the genuine sense of satisfaction of when you've helped somebody solve a creative problem through technology. I think that's that's my happy place.
Yeah, I think this is kind of an interesting point to make, because I think there's been the idea that, oh yes, now I can replace that artist, right? I can replace this artist, and this has been a point of contingency where we're looking at things and like, okay, well, where is what is that artist replaced? No, that or is that artist tool better. Because I think there was a discussion that we saw. It was a post that someone put on in our AI chat where someone had a chat and it's like, I was a creative person at some company for concept art or whatever. And I asked, and they decided to hire a bunch of prompters to do the work, right?
Yeah.
And the prompter is like pretty good image, but then I asked for changes, and then every change I made, they would adjust the prompts, and they wouldn't actually give me what I wanted. They would give me a variation that would change what was already good, as opposed to doing things. And I'm saying is like, well, why don't they just hire an artist that's good at prompting, and then they can prompt and then do the art afterwards?
Yeah. Yeah, exactly. Yeah, and I think in that example, it sounds like, the leadership decided we need to get into AI, so we just brought in people that know about AI.
Right.
We called them prompters. We didn't call them artists in the way that you might call them.
Right.
And then we just threw them next to the artists, and then asked them to work together.
How much are you paying these prompters?
Yeah, exactly. And then ask them to work together without giving them kind of clear guidelines of how they can work together. Nobody understood what the other person needed or wanted or how to interact.
Sure.
And it sounds like that example was a failure, that didn't work, and people didn't learn, unfortunately. So about
I almost think that the prompters are easier to replace than the artist. Make the artist learn how to prompt instead of the other way around.
Yeah, no. I'm going to give credit to my good friend Ben Kent at head of research now at Foundry. He's he said the people who are most likely to be out of jobs is not like artists or prompters. It's the engineers working on all this stuff. Like my job, hopefully, is most at risk, and like I'm hoping I'm going to be able to put this all to bed at some point. And the AI will just take over, but it's the engineers. Like it's the the computer vision engineers, the image process, the and even the machine learning engineers. It's like you can move, and you can move at the times, but myself and Ben, we worked on a lot of algorithms over the years, and we tried to crack some very hard things and spent years and months doing them, and then an AI algorithm does it in a week, and so instantly everybody doing that stuff is obsolete. So there's a whole those
code
jobs,
making code.
exactly, code making code. Those jobs are gone. Like they're already gone, and we're not mourning them. It's a bit it's sad. We've moved to the times, and we've kind of learned upskilled or cross-skilled or however we want to say it. We know about new ways of solving harder problems. Now, Roto, I'm gonna throw this out there. Roto is still the one proof point for me that has consistently showed that I do not think AI can replace artists. Now, whatever about the creative side of things, I think the creative side is absolutely, you're always artists,
because that seems like the thing that you would most easily replace.
Exactly. And I think it's I think certainly throughout my career, I know of very, very clever people who have all tried this and made some improvement, but it's never been, it's always been incremental at best. So Roto is my proof point. I think on the wider side of artists and creativity, whatever about changing job roles or losing jobs, there is a shift towards the more editorial side of things, and I think this is where people say, and this is where actually we will see that this is the crucible, is do we see artists being replaced for the creative bits, or do we see their value in understanding what makes something creative and valuable? Do we see that as improving? So it's all about, for me anyway, it's always been about making better tools to get to doing the creative stuff.
Sure.
And getting rid of the drudge work. That's always it. Just get that out of the way. You always have to do drudge work, whether it's like could be pipeline stuff, it could be Roto, it could be anything. It could be like like transcoding, or it could some horrible things that just you just have to do as part of the process. Get those out of the way. That's the easy stuff. But can you get an artist to a point where that stuff is out of the way, they're given a blank canvas, and they have the tools to make the thing that's in their head? And I think AI is not going to replace that anytime soon.
This is, listen, before even AI, this has always been a discussion, right? I've worked for many visual effects companies, and they always like try to use that ridiculous term called secret sauce. And it turns out, I'm going to quote, a movie, but turns out the secret sauce is people.
Yep.
Good artists are actually what make, if you want to say, oh, we have a secret sauce to make the perfect digital human, turns out it's a really good artist who knows how to do that.
Yeah, exactly. Yeah.
And if it's not some technology, it's nothing else. The technology can help them get there faster, can make their lives easier, can remove questions. But, I've always for a good science, right? I've always been a good science guy. I love good science, right? And I think that, for example, when I was working with digital humans and I was working with the guys, with ICT and Paul Debevic at the time, and we were working on Oblivion, I knew that how to apply that data set correctly, and it removed a lot of the questions, and then it looked really good, right? Yeah. And then I relied on my artistry to be able to get to the next level. But using AI tools to sort of help you get there faster, I think seems the most logical way to work, right?
Yeah, I mean, I think so. I mean, but I think the point, and I think you mentioned in a previous podcast as well about like the example of Oblivion, is like you do have to make sure everything is correctly set up, that things make sense in you've modeled the real world correctly first, and you're starting from a place that's grounded in reality. And I think that's one of the things that AI currently doesn't do very well.
It makes the most plausible reality, but it's not really reality, right?
Exactly. Now Sora is really interesting for a lot of reasons, and one of the reasons is that if they've noticed that for when you move around, it's geometrically consistent. Like if you do a structure from motion or a 3D solve on it, you can get a 3D solve on it. It has learned the world or some understanding of the world, and the same with physics of how water behaves or splashes or fluids behave, and that's really interesting. How you can use that and how that manifests itself in the way that you want it, I think is going to be the tricky bit. So, how do you, for the example of there's one of their first videos was a woman walking down kind of a street in Tokyo, street.
It's the one that everyone uses now.
Exactly.
There's a Chinese AI company that just did almost the same video to try to prove that they could do it. It's almost exactly the same.
Oh, nice.
Yeah, it's almost the same thing.
Nice, but I think it is a great example of like a simple prompt that gives you something like extraordinary. But when you with any of these videos and you spend more time with it, and you're like, I wouldn't do it like this. I would want this, or this isn't how I'd move obviously this isn't how I'd move the camera. I'd want it this way. If she's walking, like she's not she's not hitting her mark. Like all these other things, and so the catch is how do you direct that while still keeping the neat stuff like the reflections in the water, for example, or the geometry or the bright lights of the street. It's for me it's that. It's like how do you keep that the fun, playful, generative side of it while still giving you the thing that you want while still grounded in reality. To ask, is it? That seems like
it is a reasonable thing to ask, and it was great sort of being part of that film process. We haven't done or finished our short, but even just seeing directing, right? I saw Dan Thron, who was directing it, he was looking at someone and was like, okay, now give me a menacing look, right? And there were so many ways that could have been interpreted, right? And somehow it's what that actor was, that the job of the actor is to go, okay, menacing. How do I interpret menacing? And that's like, And then it's like, that's not quite what I meant. Like, think a little more crazy, think a little bit more cynical, right? These are words that are going to be hard for an AI to interpret or direct an AI to do, right?
Exactly. And like, I mean, for acting, obviously, like there's several schools of acting of how you do it versus like the intrinsic versus extrinsic versus, do you imagine a character? Do you draw on your own experiences and things? But also the director has to know the actor, and the director has an idea of, what word will I need to say to you in order to get the performance? And that might be different than the word that I would say to somebody else. And so, again, going back to your point on people, like that connection that you have, I think some people, some good generative AI artists do seem to have this connection with stable diffusion models, which is interesting in itself. But on the actors, I think there's there's so much more going on, and it's another place where I think, when you see the I love, like I said, I love Sora stuff, but then you see a headline where it says, Sam Altman of OpenAI is going to is on his way to Hollywood to go talk to Hollywood execs, and you're like, that just makes me feel sad. It's like, and I'm sure he's just talking about, I don't even know what he's talking about, but it makes it feel as though everything is cheapened. The world of filmmaking is just cheapened in that one headline, and it actually also takes away from the impressiveness of Sora, because you feel like, I shouldn't want this should feel like a tool to me. This shouldn't feel like competition.
Well, I'm going to let my other personality come through in this, which is my personality from the Martini Giant podcast, where I talk about my love of filmmaking and all this other stuff. So I think that's completely ridiculous. And that the problem with Hollywood has not necessarily been the tools that we're using. It's been the fact that it's been controlled by algorithms that say what people want to see, right? And that they're basically saying, oh, people want to see more superhero films and franchises, and that's how we're going to make our money. And I think that's wrong. But if I go back to things that are strange and weird and interesting and creative, if you look at a movie like Everything Everywhere All at Once, that tool is crazy out there in terms of the story and everything else, yet somehow was captivating and got so many people's attention. And I truly believe that that is the easy rider of today in some ways. I'm not necessarily saying I love this film. I just think it's an interesting turning point. What's also interesting is that enabled a lot of very creative people to do things very quickly because they balanced AI tools. Right? There's a lot of AI tools that were used on that specific film to be able to make their lives easier and faster and quicker and get their ideas out there. So that's what Sam Altman coming to visit an executive is not going to solve Hollywood. It's the guy in the garage who's like, how can I get my movie made faster?
Yes, exactly. And even I love the behind the scenes of Everything Everywhere All at Once was really as interesting as the film. And even the virtual production that they used, where they were like, we're not doing full stages, we're doing a couple of panels beside Michelle Yeoh's head, and we're going to play kind of footage in the background. I mean, that's the stuff that's exciting. And I think I would agree that feels like the stuff that makes interesting stuff.
Well, real quick, while we're on this subject, let's talk a little bit about training data, right? Because this has obviously been a big issue. Where you're training your data, are you getting it from what sources? And obviously, a lot of places have gotten a lot of heat about where they train their data, how they're training their data. Prompting artist names. I've had Mark Simonetti on this podcast saying, well, my name has been polluted on the internet because if you look it up, most of the stuff that comes up is AI stuff that looks like crap, but it was using my name to create it, right? So I definitely get the point of view in terms of the copyright of people's work that are being used. That from my point of view, I think the best thing to do is for that to be dealt with in the courts, where a lot of people that are very good artists are sort of collaborating to make the courts make those decisions. I think the court of public opinion should not be deciding the legality of those issues. At the same time, what do you do? How do we balance that? What do we do with chaos in terms of where we train our data, how we train our data, and what that is all about?
Yeah, good point. So on the specifics of generative AI for, say, using stable diffusion models, I agree that we do need to let the courts kind of handle the specifics on that. I think it's absolutely a sensitive matter on this. We're looking at, we have also kind of explored other ways of using fully licensed data and fully licensed models, like the ones that the folks that NVIDIA are offering and licensed through various third party licensees. So we want to make sure that we can do that nicely and safely and correctly. We also want to make sure that we're not stopping innovation. We can't wait for this to get resolved by the courts. We have to keep going. People are using these tools right now. In fact, recent surveys that we've shown have shown that most people have either explored this or are using this actively in projects now. And most people are actually quite happy with the results that they get for the tasks that they're using it. So we have to move with that. That's for the generative AI stuff. On the say the material generation work, all of the data sets we've pulled from that have either come from internal sources where we've made materials ourselves, or we've used data sets that are royalty free, Creative Commons zero license. So and we got to the point where if somebody were to ask us in the morning, hey, did you use my material for this? We can say, actually, we did or we didn't, but here's the license as we got it. And this is sort of about being safe and responsible with licensing. So I'm happy with that. There are other data sets that we'd like license through third parties, and we're in discussions with people about those. And then again, also we need to check that they in fact have the license to license that to us, because that isn't always the case. And then the other case is then what we showed in CopyCat with CopyCat and Foundry is that often you want to be able to use the customer's data. Like, we shouldn't have to know everything about all the data. We shouldn't have to be making the models. Can we present a tool in such a way that people can train their own models? Might still be using kind of our hardware, but we wouldn't have access to the data, and we wouldn't have access to the model afterwards. So there's lots of options for how we do that.
V-Ray makes images. So you can make images in V-Ray and use that to train what you want to do, right?
Exactly. Yeah. Exactly. And yeah, we have very skilled artists in house that are able to help us make this. And then the other case is that for a lot of models, you just don't need data. You just in fact, what a lot of people what I think is really underused is reinforcement learning. So the idea of like bootstrapping a thing and learning from corrections and iterations. And it's not something that's easy to integrate. I think the fact that the ecosystem that we have in Cosmos and across kind of the portfolio of software that we have at Chaos does raise some interesting questions on how we could, if we can capture data, and again in an anonymized, safe way that everybody's happy about, and also everyone's informed about what data we're capturing, how we're using it. So if anybody's giving us data, whether it's on the cloud or otherwise, that they know what the data is used for. That's important to us too. But yeah, can we create a feedback loop? Can we have a tool that, like, you're using at one studio, and you're designing buildings, you're like, I've given feedback into this system and it's given me a better model. It's made my foliage look better, and to a style that I like. I've given in this data, and it's I have a local model that now it works for me. This is now my IP. This is my I've encoded what I like about this foliage model into here, and this, I want to keep this. I don't want to give that to anybody else. So how can we incorporate this sort of this feedback mechanism but not just include your own customers' own training data, but have them know that that every brushstroke, every like manipulation that they're doing is going back and improving their system, their workflow for the next time they have to do something.
Well, let's real quick. One thing I wanted to touch on before is actually the quality of data and the quality of things that are happening in a training. Because in the early days when we were looking at things, there was a lot of what's well known now as hallucinations, right? And so I've been working on I've always been playing around with these things, right? I've been always trying to, that's how I know when things are getting better. So yesterday I had almost a half-hour conversation with ChatGPT about my upcoming fly fishing trip to Belize, and finding out like how much it knows about fly fishing in Belize, right? And turns out it's gotten way better. Like, it really knew stuff, right? Maybe because I've had this conversation before. I don't know, right? But it's kind of fascinating that it got so much better in the last few months, right? Because before it was making up all kinds of stuff that didn't make any sense, right? But now it's getting so much better. And so I was like, okay, well, that's interesting. So what are your thoughts about hallucination? That's number one. And it's semi-related to that is bias, like how bias is interpreted into this data to sort of steer it into a specific direction of what we're looking at.
Yeah, I mean, on the bias question, I think I mean, I don't have a good answer because I think as a 40-year-old white male,
right,
like it reflects my world pretty accurately.
Sure.
So it's I'm aware that things are very, and also 40-year-old male, white male computer scientist, English speaking, like it's going to be a real echo chamber with me. I'm not going to be aware of kind of strong kind of biases. But on the hallucination thing, yeah, I would agree that it does give it does hallucinate some interesting fun things, and particularly like for medical stuff, like, so when you ask, you always want to know, do I need to go to the hospital with this thing I've just found on me? And if you push it enough, it will give you something, but then you don't know, has it just made it up? And especially if it knows, if it's a bit unsure. The neat thing though about it is like, you can ask it to tell you when it's unsure, and you can ask it like at the end of each of your replies, please tell me how sure you are and confident you are of these things, or else you can also,
because they always sound very confident.
Yeah, exactly. Yeah, very confident. I know, like, this isn't going to be like, and this is going to sound like an advertisement for the pro version of ChatGPT, but in our like chaos team one, you can ask it to say, there's a box that says, how do you want to be addressed? How do you want me to interact with me? And you can say, you can specify, I am this person. You can describe yourself, and you can say, I prefer short answers. I prefer you not to be cocky, not to be overconfident, and it will dial it all back. And it's much nicer. Now you can also tell it to answer you in various styles. So like I had for a few days, I had it answering back as a flirtatious Cockney barmaid from London. Who wouldn't? And I would get all my answers back in this. And interestingly, it would give me different answers that it would.
Oh, interesting.
Yeah, exactly. So like, and it makes sense because you're asking it to take on this different perspective, and it gives you back different answers. But then it's really embarrassing when I had to share some of these chats with Vlado, where I was like, oh no, I can't, like, it all reads like this, like Cockney, like flirty barmaid.
What can
like,
I get you love?
This isn't very professional at all. But it gave, yeah, exactly, yeah. Exactly. So, but it gave me the answers that I wanted. But
what was really funny, and this goes back to our noise thing that you were talking about, is in the very, very early days, I had a tool that I was looking at called Visions of Chaos, but they had a bunch of machine learning stuff in there, and you could download all these open source language models that are out there, and there's tons of them, right? It's not just ChatGPT. There's a lot of them out there that are open. And he and I had a whole series of questions that are about things like, and it was very funny because Vlado's questions were very Vlado-centric and mine were very Chris-centric. And we would ask them all the same questions. And the ones that were very, new or experimental models, when they would fail, it was hilarious because they would start with a normal answer. And really what they're trying to do is just trying to interpret the next word that's going to be there. Yep. And they would start off correctly. And then by the end, they would just be a bunch of words that made no sense next to each other because it had lost the thread. It's like they had a seizure. It was just a very strange thing to sort of watch. But what was interesting, you were saying how you were talking to that personality. So I chose, like on ChatGPT on the phone, I just chose the default voice personality, which bizarrely sounds exactly like Scarlett Johansson in Her, right? Like, so, but then I asked this, can you have a conversation with two people? Like, and I was like, oh, this is an interesting thing. Like if there's two people and we both want to have a conversation, and that ChatGPT said, yes. However, you need to say who you are before you say anything. I was like, oh, you can't interpret my voice? And he goes, I'm not reading voices. I'm just reading the text that's interpreted from it. And I was very interesting to sort of think about, wait, I am not talking to a real person. But it was so very, very interesting to sort of think about that process.
Yeah. And that the Scarlett Johansson voice is really creepy. Like it's really endearing because it's immediately you connect straight away with it.
Just like her.
Like I mean, Yeah, exactly. Yeah, like we have I've got 2 kids. You mentioned about hallucinations. So my 5-year-old daughter appeared as a hallucination beside me a second ago. But we do have a 7-year-old son, and we do bedtime stories with ChatGPT, and we have like prompts. Yeah, and we have prompts that we have an ongoing story, like it's been running for a while,
and so it remembers.
But what you do is it remembers. I mean, up to the context window size, but you do a kind of a choose your own adventure, like do this or that, and they get to say a thing, and again, I think it probably in this case it works well because ChatGPT doesn't know whose voice is talking, so they just shout and they just say what they want to happen next, and then the story goes off in this way, and they have little markers, and like there's different, like there's like the mayor is a funny character who keeps coming back and has its own thing. There's like the town is a funny thing, the forest is a funny thing. Like they have different, it's developed this world has grown out of this, and this is purely through just conversation with the app on the phone, and like it's they love it. It's like it's great. But I also chat regularly with ChatGPT on my phone in the car after dropping the kids, because I have I would talk about like what I'm going to do during the day, and what things I need to do, like what's on my to-do list, and then also things I'm concerned about, or things that, and then I have a prompt. Then I have a kind of a trigger in the prompt that when I trigger it, it'll generate a bunch of code. And then the code I copy and paste into a terminal then afterwards, and then it does things like updates Jira tickets. It adds things to my calendar.
It's doing this while you're driving.
It does a whole bunch of other stuff. Oh, no. I'm not like this is. That would be neat if I was doing all this, but no, I try not to be on a terminal while driving. It's.
I mean, it would be wonderful if it did it for you, so you don't have to even look at the terminal. Just add this code and to answer this Jira ticket.
Yeah, I mean, there I think there is there are ways of automating it, but I think the thing for me is that sticks out with this ChatGPT thing is, and I love it, is like it's a co-pilot. Mm-hmm. Like I have a thing open the whole time, and there's different prompts that I go to like it's like different personalities and things, and for I need to solve different tasks, and this is the thing that I try to get over to people is like when you start getting into it and into the rhythm and learning about how to use the prompts, and it's going back to if there's hallucinations or biases, you can inject into you can work around them. You still need to identify them, and where and why it's failing. But in terms of like workflow and efficiency and productivity, like it's incredible. Like this alone I think is transformative, and this is still being developed and growing.
Right. Interesting. Well, I think it's really cool. I love the fact that you're part of the company and I can talk to you about all this cool stuff all the time. And as I knew we were going to go long, but kind of went down the rabbit hole, which is what you do when you talk about AI. You get down rabbit holes. But it's cool, and I'm very excited about the stuff that you guys are doing. And obviously, a lot of the news has come out that we're working on some of these things. So I'm very excited to see those things. I know some of the things you can talk about, some you can't talk about. But we'll put all of that stuff on the page in terms of all the news on that. So Dan, thanks so much for doing this, man. It's been really cool. I'm sure we will have this. My feeling is we're going to probably do this every 6 months because everything's going to change and we need to catch up with you again.
Oh, perfect. Yeah. No, but Chris, thank you so much for having me on the podcast. I mean, I'm long time listener and fan, and genuinely honored and wonderful chat. And yeah, I'm delighted to be brought into the chaos fold, and it's this is going to sound very what's the word, like self-aggrandizing, or saying how wonderful chaos is, but I am really excited about the things that we're going to share. I did come to chaos for a very specific reason, and I'm excited about some of the stuff we're sharing. I think we are doing some very interesting stuff. I think
the Innovation Lab is quite cool. The people involved in the Innovation Lab are really cool, and working with Vlado every day is really quite an honor to me, honestly. Yeah, it's quite cool having Vlado as a boss. I have to say. For sure, it's quite cool. Yeah, for sure. Well, thanks, Dan. Yeah. And I have the Vantage and Project Arena stuff. Oh yeah. Also, I have to say, oh man, it's my dream. It's happening, and honestly, a lot of that is actually because of very, very, very clever denoising, which is very AI based, right? So that's sort of the thing that propelled
exactly.
it to where it is today.
Yeah, very cool.